Hi, my name is Robert Wolfe. Today I'll be discussing research on hypodescent and visual semantic AI. First, I'll summarize our findings, then move on to background on the AI model we studied and the psychological theory we grounded our research in. Then I'll cover our sources of data, followed by a description of our experiments and results. And finally, I'll discuss the implications of this research for AI and society. The model we examine in this research is CLIP. CLIP jointly trains a language model and an image encoder and uses cosine similarity to pair an image with its text caption. We started with a straightforward research question. Does black plus white equal black in visual semantic AI? Put another way, does CLIP associate according to a rule of hypodescent, or one-drop rule? Drawing on prior work in psychology, we morphed images of individuals who self-identify as Asian, Black, or Latino into images of individuals who self-identify as white. At the midway point of these series of morphed images, we found that CLIP associates the majority of images according to a rule of hypodescent, with a primary effect for images of women. Next we asked, does person equal white in visual semantic AI? Put another way, is white encoded as a default race in CLIP? We found that image associations with a person text prompt with race omitted were more strongly correlated with associations with a white text prompt than with any other race or ethnicity. And finally, does bias correlate with black in visual semantic AI? We found that the magnitude of bias measured using a word embedding association test correlated with the association with black, and that bias was also indicated for images of multiracial individuals. We'll briefly review the architecture of CLIP. CLIP forms four kinds of embeddings: contextualized word embeddings, sentence embeddings, image embeddings, and multimodal projections of image and sentence embeddings. The CLIP text encoder uses the architecture of GPT-2, which was trained to predict the next word in the sequence. GPT-2 generates contextualized word embeddings to form a prediction of the next word in its vocabulary. CLIP encodes a sentence embedding using the GPT-2 architecture, and then projects it to a joint visual semantic embedding space. CLIP also learns image embeddings using a vision transformer or a ResNet and projects those to the same joint visual semantic embedding space. In this space, cosine similarity ranks, retrieves, and classifies images. So that's an overview of CLIP. Now let's discuss what hypodescent refers to and why it's an important bias to study. Hypodescent refers to the association of multiracial individuals with a disadvantaged race or ethnicity as opposed to the equally legitimate advantaged parent group. In human subjects, hypodescent categorizations are associated with a preference for group-based hierarchy. Hypodescent may be related to selective attention, wherein humans direct more attention to the traits they observe infrequently and later in life. Historically, hypodescent was used to facilitate the expansion of slavery and to enforce segregation and racial hierarchy. In practice, hypodescent perpetuates racial boundaries despite changing demographics and social structures. We based our work on the prior research of Ho and colleagues, and specifically in an experiment that morphed an image of an Asian or Black individual into an image of a white individual over a series of 21 images. This research found evidence for hypodescent in that human subjects were more likely to associate the central image with Asian or Black rather than with white. To replicate this work in AI, we used the 597 images available in the Chicago Face database. These include images of individuals who self-identify as Asian, Black, Latino, and white. Following Ho and colleagues, we used StyleGAN2 ADA to generate 21 image morph series of Asian, Black, or Latino individuals into images of white individuals. We produce 1,000 of these morph series for each pairing of a starting and ending race or ethnicity. If hypodescent occurs in CLIP, we would expect the model to associate the center images of the morph series with a minority race or ethnicity rather than with white. To quantify this, we took the number of times out of 1,000 series that the association with the minority group text prompt was higher than the association with a white text prompt. The results showed that CLIP associates according to a rule of hypodescent for all 3 female series and for the black-white male series. The most significant effects were observed for the Asian-white female series. Specifically, 89% of Asian-white female images were associated with Asian at the middle step of the morph series, 75% of Latino-white female images were associated with Latina, and 69% of black-white images were associated with black. 53% of black-white male images were associated with black. The results reflect hypodescent in the model with a primary effect for women. Next, we tested whether white is encoded as a default race in CLIP. To do this, we calculated the cosine similarity of each image with a photo of a person with race or ethnicity omitted. Then we took the cosine similarity of each image with the white text prompt and with the source race or ethnicity for the series. Across the morph series we generated, the cosine similarity of an image with the person text label is nearly indistinguishable from that of the white text label, suggesting that white is encoded as a default race and that other races and ethnicities are defined in the model based on their deviation from white. This is further supported by the correlation between image associations for person and image associations for white, which are higher than for any other race or ethnicity. Let's further visualize this. We observe that the person text prompt does not change much in how similar it is to the images over the course of the morph series. However, we find that the white text prompt also does not change much with how similar it is to the images over the course of the morph series and has nearly equivalent associations with the images as the person label. On the other hand, associations with black vary significantly across the morph series, such that an image is associated with black to the extent that it departs from the white default. Finally, we tested valence bias in the model using the single category embedding association test, or SCE. SCE measures the differential association of an image vector with 2 groups of attribute words. To measure valence bias, we used words denoting pleasantness and unpleasantness, which were used in prior research in AI and psychology. If CLIP does not exhibit valence bias, we would not expect race or ethnicity to have an effect on the image's valence associations. However, we find that the model does in fact exhibit valence bias and associates white individuals with pleasantness and black individuals with unpleasantness. Moreover, images of multiracial individuals are also subject to valence bias, where they are more similar to images of black individuals. Further supporting this, we found that bias correlates with the association with black, both for male images and for female images. So what are the takeaways of this research? First, that visual semantic AI associates multiracial individuals according to a rule of hypodescent, with a primary effect for images of women. Second, that the model encodes white as a default race. And third, that intrinsic bias magnitude correlates with the association with black in the model, and that this bias extends to images of multiracial individuals as well. So why do we observe a primary effect for images of women? First, we know from prior research that CLIP is more likely to pair text describing physical features with images of women, which may mean that it pays more attention to a feature like race or ethnicity. Second, women of color are significantly underrepresented in computer vision training corpora, which may influence a bias that is thought to be caused in part by selective attention. So what effect might this bias have on AI and on society? First, models that use the CLIP embedding space are likely to inherit the biases learned by CLIP. For example, DALL-E 2 is a generative image model that forms novel images by decoding from the CLIP latent space. The DALL-E 2 model card notes that it overrepresents white individuals in the images it generates, which may be a result of CLIP encoding white as a default. Moreover, given the widespread deployment of AI and its ease of use, the associations of models like CLIP may end up influencing how humans perceive other humans. Our research does have limitations. First, we assessed only the most commonly used CLIP model. Second, GANs may themselves be biased. They're known to lighten skin tone and in some cases may generate lower quality images for underrepresented individuals. We also note that changing text prompts will have an effect on the results because CLIP representations are contextual. And finally, our analysis is limited to the races and ethnicities as well as the genders included in the Chicago Face database. Future work might address what causes hypodescent in visual semantic AI as well as how to mitigate it, and might expand this research to other visual semantic embedding spaces and to downstream language and image tasks. I want to say thank you to my brilliant collaborators, Dr. Mahzarin, Banaji, and Dr. Aylin, Caliskan. Please feel free to contact us at any of the emails provided. We've made our code public on GitHub. Thanks so much.